All right, I think most people are here. So let's get started. Welcome everyone. This is CMPT 727 Statistical Machine Learning. I'm Max Lebrecht. So I want to start off talking today about why this course exists and what I hope you'll get out of it. We'll talk a bit more today, once we're done with that, about the course format, logistics, all that stuff. We won't start on content today. We'll start on that on Thursday. Okay, so this is a course on statistical machine learning. So perhaps we should start by asking the question, why machine learning? If you're here, I don't think I have to make that case to you, but let's do it anyway. Machine learning concerns algorithms that improve with access to data. And one thing we've learned recently over the past decade or so is that by leveraging all the data we have from all the various sensors that exist in the world, from credit card transactions to photos to web traffic and many, many more sources of data, by leveraging all that data, we can create much better algorithms than we could by designing them ourselves. And as you know, machine learning already powers very many of the things that you do in the world, including your camera, most of the things you do on the web, finance, biology, biology meaning our innovations in biology, engineering, all of these things are increasingly becoming powered by machine learning. And I think you should expect that this only scratches the surface. Lots of data in the world is relatively unutilized. You could imagine, ultimately, in order to create the best algorithms for the things we want to do in the world, leveraging all the text in the world, all the images and video on the internet, all the genome sequences, all the sensors readings from people's actions in the world, buying things, car traffic, energy usage, and so on. You could imagine leveraging all that data, and once more, the tasks that we can perform using machine learning right now are sophisticated compared to what they were a decade ago, but we should expect that much more is possible, that these kind of only scratch the surface of what's possible. We're doing things with machine learning that are relatively simple in the scheme of what, for example, a human can do, things like detecting faces or in images or parts of speech in text. That's relatively simple. Now that's getting more sophisticated, but we're a long ways off from what I think one would expect to be possible. So that is to say that machine learning is already a very core part of computation in the world, and I think we can expect that only to increase over the next few decades. I think anything you want to do that's impactful over the next 30 or so years, that is your career, whether or not you are interested in a career in research or industry, I think anything you're going to do in your career that's innovative is likely to have machine learning as a core part of it. Okay, so that's why machine learning. Why statistical machine learning? By the way, statistical machine learning maybe isn't the best name. A less succinct name for this course, and in fact, the plan is to change the name of the course to this. A better name for the course might be Mathematical, Probabilistic, and Statistical Foundations of Machine Learning. So the key question we're aiming to answer in this course is why. That is, when we're interested in a given problem, why is one method better than another? If we're proposing some algorithm, why that algorithm? Why not something else? and so on. So to do that, we need to think deeply and precisely about machine learning. And we do that by precisely stating and proving rules and behaviors we're interested in learning about machine learning algorithms. And another name for doing something where you are working precisely and formally is mathematics. And specifically, we're interested in the subfields of mathematics of probability and statistics. You might also lump formal logic in there. So what I'm hoping you'll get out of this course is to be able to, when approached with some real world problem where you think learning will be effective, I want you to be able to, one, frame that learning problem in a precise way, mathematically, down to the level of mathematical precision. What is the data I have? What is my goal? Can I state in a mathematical expression what my goal is, my objective function? That is how well I think I've solved this problem, and then derive an algorithm for solving it. And that might be something off the shelf. Maybe you determine the thing to do is just take your data and throw it into Keras, or maybe what you find is that actually you need to derive something else. And I think that comes up very often in practice, and you'll, even if you ultimately aren't developing your own methods, meaning if you're not more on the research side, you're more on the applied side of machine learning, having the understanding such that you understand why one method works over another, I think, is extremely valuable. And then I want you to be able to reason about which algorithms perform better or worse in terms of computation time, expected performance, generalization, and so on. So this is a class that's focusing mostly on the, like I said, the mathematical, probabilistic, and statistical foundations. If you've taken CMDC 726 or something equivalent, which I hope you have, there won't be too many new methods here. There'll be some, in particularly when we get to probabilistic graphical models. I think you'll see some algorithms and machine learning methods that you haven't seen before. But most of what I'm aiming you to get from this course is from a shallow foundation that you've built from a course like 726. I want to build a much deeper foundation, understanding and being able to prove the properties of these methods. So why do I think that's important? Machine learning, especially very recently, is becoming very accessible. You can easily download scikit-learn in Python and start download a data set and start plugging data sets into methods. And I could teach you a class about what methods exist and how they work and that kind of thing. But I don't even necessarily need to teach you that. You can pull up the scikit-learn documentation and understand that pretty quickly for yourself. But once you do that, your results can be rather opaque. Maybe your algorithm performs in the way you'd like it to, maybe it doesn't. And if it doesn't, what do you do about it? So that's reason number one. Reason number two is that principles and foundations are durable. Machine learning is moving very quickly, as all of you, I think, know. The state of the art shifts quickly. So if I were teaching you a class on what machine learning methods were trendy and thought to be really powerful, if I taught you that class 10 years ago, we'd all be talking about support vector machines and kernels. 5 years ago, we'd all be talking about unsupervised pre-training of neural networks, which is something that used to be talked about a lot and is not so popular anymore. Today, we'd be talking about convolutional neural networks with stochastic gradient descent, maybe talking about transformers or graph convolutions. But if the past is any guide, I think you'd expect all those things quickly to be replaced in kind of the popular imagining of what is the state of the art with something else. And if you spend your degree learning about what was popular when you were taking your degree, that knowledge might not be very useful 10 years from now when you're trying to apply it in your career. Conversely, foundations are timeless. Most of what we're going to talk about in this course has been known for 20 years, although we're going to put it in a modern context. And it's still relevant, having been known 20 years ago. I have no doubt that it'll continue to be relevant 20 years from now. A third reason is that this information, I think, can be learned effectively in a graduate course setting, whereas not learned effectively in practice if you're actually a practitioner out doing research or applying machine learning. I think there's a lot you can learn from jumping into a research competition or an internship at a machine learning company or a Kaggle competition and just getting your hands dirty with data. And I absolutely think all of you should be doing that if you're not already. But there's not that much I can do to help you with that. As an instructor of a largish class. On the other hand, I think this type of information, understanding mathematical principles, I think you really need to sit down and spend some time with a textbook, spend some time working on doing proofs with your peers. I don't have another good way to do that other than in a course. So that's why I think now is the time to make sure you learn that information in this part of your training. I think a good analogy for this class is a physics class. So in physics, they don't teach you that gravity exists. You already have great intuition for what happens when you drop an object. Physics teaches you universally, broadly applicable principles, rules you can use to manipulate the world. So I hope you can think of this class as kind of like the physics class of machine learning. What are the what's the law of thermodynamics when it comes to machine learning? Good. Again, please do, if you have any questions at any point, feel free to unmute or to type it in chat. I have chat open, so I should see your question. Okay, so that's the topic of the course. Hopefully that helps you decide if this course is for you. Now about kind of the logistics of the course. This is the third year of this course being offered. I developed this course and offered it for the first time 2 years ago. This is the third year. This offering will be quite similar to last year's. So if you know anyone who's taken it, they can probably tell you what to expect. This course is intended for anyone who's taken a introductory machine learning course like 726. Now, I know that there are a lot of different backgrounds here. There are people from computer science, from math, statistics, biology. I'm going to try to bring everyone in. That means that at some point, any given person will almost certainly be bored. So, so bear with me if I'm covering topics that you're very comfortable with. And hopefully for everyone here, there will be content that is new and valuable to you. Okay, so this course is remote. It'll be remote for the whole semester. My goal in that format is to maximize the good qualities of the remote format and minimize the bad qualities. So I think everyone here now has had a bit of experience with remote learning, as have I. And one thing I think we've learned is that there are actually some things that we can do in this format that we couldn't do in in-person learning. Of course, there are plenty of drawbacks, but we're going to do our best to maximize the advantages. So I'm going to talk more in detail, but we're going to have recorded lectures for this course, and that you can watch on your own time, and there'll be assignments only, no exams. I'm going to try to maximize everything about this course in how it's structured is aimed at maximizing our interaction between me and all of you and among yourselves, because I think that's often where you get the most benefit. And I think in some ways we can really optimize our interactions even more than you might get from, you're all sitting in a lecture hall together and maybe you chit chat with your neighbor from time to time. But I think we can do better by optimizing it for it specifically. Okay, so let me tell you more about kind of the specifics of the course. So if there's one thing to get away from this lecture is the web page. You should have all gotten an email with this link. If you didn't, write it down now. I'll leave it up for a little while. Everything I'm talking about now is available on the web page. So, so don't feel the need necessarily to take notes on all these details or anything. Everything will be on the web page. I'll give people just one more second to type, just in case anyone is a slow writer. Okay, so again, all this is on the web page, but let me go over the specifics. So this course will closely follow these two textbooks from Murphy. What's Murphy's first name? Kevin Murphy. These are excellent textbooks. So the second book on this list, book 2 here, was published a couple of years ago. Kevin Murphy is now re-releasing it as a 2-part series. So book number 1 on this list is actually the first of the two-part series. We're going to use mostly book 1. Book 2 of the 2-part series is not currently released, so it's not on this list. It's expected to be released in like a few weeks. So if it's released and if it's good, I will have a switch over to that textbook for the second part of the course that's on probabilistic graphical models. If not, we'll continue with the plan, which is once we're done with the content that we're interested in book 1, we're going to switch over to looking at probabilistic graphical models in the second book on this list, which is the older textbook. There's a question in chat, but I don't exactly understand it. The email on the course web page is written as maxwio@sfu.ca, which is at and dot written out. So the reason I didn't write out the at sign and the period is so that it doesn't get caught by spam bots on the internet. Hopefully that answers your question. Okay, I already talked about that. Okay, like I said, lectures will be recorded and posted. So I'm going to record them asynchronously. And we'll have one synchronous interactive Zoom session per week. That will be in the Thursday slot, 10:30 to 12:20. I'm going to try something new. excuse me. I'm gonna try something new for this offering, where we're going to watch for the first hour of the session. We're going to watch this week's lecture synchronously. So what I'm going to do is come onto Zoom, and I'm just going to hit play on the recorded video, and we can all sort of watch it together. And then you can ask any questions in the Zoom chat, and I can pause the video and answer anyone's questions or answer them in Zoom chat. I'm going to see how that dynamic works. You should certainly, in a couple of weeks, I'll give a chance for you to give some feedback on whether or not this format is helpful for you. One bit of feedback I got from previous remote courses that have had recorded lectures is the recorded lectures are nice, but there's sort of no chance to ask questions like you have in a synchronous course. So I'm hoping this can serve that purpose. So we can think about it kind of like as office hours. You come, watch the lecture with me, and ask any questions. Chat in the Zoom chat with your peers, and hopefully that's a valuable way to watch the lectures. It's just 1 hour or 50 minutes, so we're not going to get through all the lectures every week. The rest you'll watch in your own time, but hopefully we can get through a decent amount of them and have that be a valuable time. But again, this is an experiment. We'll do it for the first few weeks and see how it goes. Part 2 is for the next hour. We will work on the assignments along with your group. I'll talk about groups in a minute. You'll be in a group with 4 to 5 of your peers, and you'll spend that time working with them. I will come around to all the groups and answer any questions you have, and anything like that. We're not going to use the Monday lecture time that's scheduled for this class. This will be the only Monday lecture for the semester, except for next Monday. I'll talk about what's happening next Monday in a little bit, but it'll be this Monday, 1 week from now, and then most likely not for the rest of the semester, unless something comes up and we decide to change course mid semester. Hopefully that answers the question. Okay, so the main focus of this course is going to be on written problem sets. There'll be 1 problem set per week. There'll be math and written questions. So there'll be I think everyone here is familiar with problem sets. So it's going to pose a problem to you using the course content. You're gonna write a solution. You'll have 2 opportunities to submit each problem set, or you will do 2 submissions for each problem set. So the main submission will be the first one, which is your individual submission. You'll write up a submission, you'll submit it. As usual, it will be graded. We'll try to get the grades to you in a couple of days after the due date. And that's worth 2/3 of your grade. Then do 1 week later, you'll meet with your group, and together you'll prepare a group submission, and that's due 1 week after. So the goal of the group submission is to encourage you to help each other and give you a chance to understand and fix any mistakes in your first submission, and have a chance to improve your grade over what you got in the first submission. And it's worth 1/3 of the assignment grade. I didn't write that on the slide. Yes. Oh, and then there'll be 2 coding projects, 1 for a midterm and 1 for the final. So these are replacing midterm and final exams. Hopefully they'll also give you some opportunity to apply the concepts we are talking about from more of a theoretical perspective. Okay, so like I said, you'll be divided into groups. Groups will be about 4 to 5 people. So you will meet with your group each week in the Thursday session. I'll break everyone into breakout groups. You will you'll work together. You'll submit one document for your group assignment submission. I'm imagining that in that group session, you'll, in the first 30 minutes or so, fix any issues, prepare that group submission together, figure out what each person got off, try to fix mistakes, and then you'll prepare that and submit it, or put someone in charge of submitting it for the group. And then for the rest of that time, you'll work with your group on the following assignment. There will be a survey that's sent around. I'll send that out. I'll put the link in the slides, in just a couple slides, and I'll send it out on the email as well. So there'll be a couple of things to answer in that group survey. Number one is, if for any reason you can't attend the synchronous sessions, let me know, in particular for those who are in a different time zone. So if there are a couple people who are in a different time zone, a significantly different time zone where it's the middle of the night in our normal class time, what we can do is we can put all of you into a group, and you can meet at a time that's convenient for you, and I'll ask you to recreate the class session. So please, watch the lecture together and then do your group assignment together. I won't be there to discuss with you, of course, but at least you'll have each other to be in the same group. And then second, you can request one person to be in the same group as you if you have a buddy that you like to work on assignments together. And then other than that, I'm going to try to optimize the groups to be diverse according to, in particular, to people's home country. So I asked everyone, what's your home country? Where did you do your undergrad? Please put that in, and I'll try to get people from different backgrounds, because hopefully then you'll be able to share kind of your strengths. Okay, so here's the weekly schedule. I think I said this, but here's what you should imagine yourself doing each week. So let's imagine it's week 5, just so we can use the numbers. So before our Thursday session, you should read the assigned textbook sections. Then in our Zoom session on Thursday, we will watch the lectures for week 5 together, and then work on the assignment with your group. You'll do 2 parts in that group session. First, like I said, you'll finish up the group submission for assignment 4. That's the one that was due, for the initial submission was due earlier that week. And then you'll continue and work on assignment 5. So then after that, you can watch the remaining lectures, finish the assignment, and then on Monday, the assignment 5 submission is due. Good. Hopefully that answers your question. So just something on timing. So the assignments should be relatively small. I've tried not to make the workload unreasonable for this course, but it is weekly. So just be aware that the assignments come fast. I don't think they're unreasonable in terms of length, but don't get behind, because you'll have trouble catching up. Okay, LaTeX. LaTeX will be required for the assignment submissions. It's not required for assignment 1, which I'll talk about in just a second, but it will be required for all the subsequent assignments. LaTeX, for anyone who's not familiar with it, is a typesetting language. It's a very powerful tool for making beautiful manuscripts. Most papers you see in CS are formatted in LaTeX. It's great for handling math in particular. So we will be giving you a primer on LaTeX. Hung will lead that on the Monday session 1 week from today. So that's why I said that's the second Monday session. After that, we won't have sessions on Monday. Hung will be leading a session on guiding you through LaTeX if you haven't used it before. Assignment 2 and on, you'll be required to use LaTeX. Speaking of, I forgot to introduce Hung. Hung Lu is our TA for this course. Hung has been TAing with me for 4 years now, I think. Hung is an excellent TA. I think he'll be of a great help to you. So his email is on the site if you need it for any reason. So please get help from Hung as needed. In particular, you should send your inquiries about any questions for the assignments or questions on your grade. Those should go to Hung. Okay, I mentioned this briefly, prerequisites for this course. So you might have seen on the syllabus that there are no official prerequisites. The reason for that is that I know many of you come from various universities where you did your master's or undergrad, and many of you have taken a machine learning course that's similar to CMDT 726, but may not be exactly identical. So I'm letting everyone here decide for themselves if they think if this course is relevant for you, if it's within your background. That said, I highly discourage anyone taking this course if you haven't had a course that's equivalent to 726. And to help you determine that, there'll be a qualifying assignment. I'll talk about that in just a second. The other prerequisite is a strong foundation in probability and linear algebra. We'll do a brief sort of catch-up reminder for those topics in this course, but if you haven't had courses on probability and linear algebra, I think you'll have a really hard time in this course. Do I have a slide on the qualifying assignment? Here I do. Okay, so we're having a qualifying assignment that's due 1 week from today. You shouldn't need any of the lectures yet, so you can start working on that now. It's up on the website. You should be able to do it with your existing knowledge and perhaps briefly referencing our textbook or Wikipedia. That said, if you find you need to reread a whole textbook chapter as you try to do assignment 1, I think that's a good sign that this class is not for you, and you should probably take 726 first. The way the grading it's going to work for assignment 1 is we'll give you a score. That is, tell you which questions you got right and wrong on assignment 1, but everyone gets full points on the assignment for the purposes of calculating your grade. So that's just to encourage you to fairly represent your skills when it comes to the qualifying assignment. And then we'll recommend anyone who seemed to struggle on the qualifying assignment, will recommend to you that maybe this course isn't for you. I'm not going to kick anyone out of the course who really wants to take it. And again, any format is okay. It doesn't have to be LaTeX, just has to be some PDF. Obviously, try to make sure it's legible for the sake of grading. Okay, collaboration policy on assignments. So as I've said, I highly encourage you to work with your peers in this course, both on the problem sets and the coding assignments. Where I draw the line on plagiarism of your peers is all writing must be your own. So it's not acceptable to copy and paste either text from your peer or from the internet or anywhere else, or obviously equivalently would be to verbatim transcribe someone else's text. So as you're writing, you shouldn't be looking at some other screen and copying it exactly. Certainly, it's fine to consult with one of your peers to get an idea about a solution and go put that into your assignment. Same goes with code. You can talk about how to code your solution, but please no copying. Okay, just the last couple things. Enrollment, there should be plenty of space in the course. Everyone should get in. I know some people are on the wait list for some reason. This is an issue, I believe, with Sims. It's not putting people into the course. Hopefully that's fixed now. So if you're on the wait list, please send me an email. I should be able to get it fixed. Anyone who'd like to attend the course informally, not for a grade, you're welcome to do that. So I'll let me know, and you're welcome to attend all the lectures. We'll put you into a group. Just let me know if you intend to take the class informally, if you intend to do all the assignments or not. If you don't intend to do the assignments, we might create an auditors group of people who just want to attend and maybe want to chat with each other in the group session, but not actually work on the assignment. I don't want to put you in a group if you're not working on the assignment with other people who are working on it, because then they're down one group member. But yes, any kind of informal attendance is totally fine with me. You'll just need the web page, which is viewable by anyone. You don't even need to be a SFU student, conceivably. Okay, the survey, as I said, for the group assignment, do the survey. The survey is due this Wednesday. That is 2 days from today. So please do it, ideally right after this session we have right now. The link is on the web page. It's also on the slide, as you can see. So again, the two main questions are: put down your whether or not you'd like someone else to be in your group. There's a buddy you like to do assignments with, and then put down if you have any issues with the remote format, or sorry, with the time of the interactive session. If you don't submit it, we'll just assign you to a group randomly. So please do submit it. Last thing is we'll have a discussion forum on Canvas. Last year, the discussion forum was sort of moderately used. I think people got a lot of the discussion they wanted in their group sessions. That said, please do use it liberally. Feel free to post anything, questions about the problem set, anything you found exciting involving topics relevant to the course, machine learning, probability statistics, AI. Feel free to post it on Canvas. And please answer questions written there by your peers. One thing, I don't have a slide on this. There's a grading breakdown posted on the website. I believe it's 10% attendance, 65% written assignments, 25% coding assignments. I think that's right. But with the web page has the actual grading breakdown. So the participation is mandatory. By the way, you are graded for participation. The reason for that is your peers are counting on you to help them with their group submission. So please do try to attend. There are 2 free attendance days, so as you can skip 2 days with no penalty. Okay, that's it, I believe. Yes. Okay, so that's all I have on sort of course logistics. As I said, we'll start on content on Thursdays. I'll try to post this week's lectures tonight. And please let me know if there are any questions. Give people just a minute in case there are questions.